WQeMS is a platform which provides an operational water quality emergency monitoring service, exploiting Sentinel data. The main access point to the platform for the user is the web portal. Each of the services, functionalities, and tools are described in a dedicated page, which is reachable by clicking on the related cards on the home page. Each service is described including results, gains, specifications, and a preview of the geospatial maps. In order to request a service, the user should be registered and authenticated. At this point, it is first of all requested to select the water body to be monitored by uploading a shapefile containing one or more areas of interest, or by selecting from a list of water bodies that were already specified by the user in a previous request. A section related to the selection of services includes 4 main areas related to each of the main service components. For each of these, a list of sub-services with the related parameters is present. For each service, the user can specify the on-demand or the continuous 2 monitoring modality. The continuous mode continuously monitors water bodies, generates geospatial maps each day, and detects water-related issues. On the other hand, the on-demand mode is about the generation of one-off geospatial maps of a given area at a given time. In the example, the user is selecting the 2 dates and hydroperiod services of the Land Water Transition Zone Change Detection Service. When the request gets submitted, the user can visualize a list of requests that the one did with the specific details in a dedicated section of the portal. For each area of interest, the details are listed including the specific modality of request, start date, end date, and the request status, which informs if the request has been already accepted or not by the administration team. As soon as the request gets accepted by the administrator, the user can visualize the generated data through the Map and Data Navigator. It enables to visualize on a map the different parameters, providing information regarding the specific values for each pixel. It is able to generate histograms and pie charts that depict statistics related to the overall area visualized. If available, it is possible to select geospatial maps of multiple dates and compare multiple water bodies through pie charts by selecting the different parameters. In the example, it is shown a comparison of how much water to land and land to water areas of the Doretta Lake are detected in 2 different periods of time, thanks to the 2 date service of the Land Water Transition Zone Change components. It is possible to animate the flood's data products, which in the example refers to the Doretta Lake, and also visualize the related metadata directly by clicking on the user interface. In the metadata, there is a lot of information, including the quality of the data generated, such as the kappa coefficient, represented through the quality ML vocabulary, which is also described in a dedicated wiki. The user can also provide feedback to the specific data layer. For example, if there are some data products that cannot be well understood, or the data product has some issues in visualization, then the user can leave a comment. There are also other ways through which the user can navigate and download data products. The file server enables the navigation and the download of TIFF and XML files as generated by the system. These are all data products that users are able to access to if they have the permission. You can also use the FTPS directory provided by the platform. In this example, it is showed how to use the Fuzilla client to connect to it. By using the same credentials that the user used to access the web portal, the one can list and navigate to the different folders and download each file. The platform also offers a WQeMS endpoint, which is provided by an internal GeoServer. If the user owns a GIS or a DSS, the one can import this data flow directly in that system, selecting the specific data layers and the different granules and dimensions provided by the platform. The catalog is a web application that enables users to search and visualize the data products generated in the platform by providing an open view of the metadata referred to data products for water body monitored and service. Upon accessing the catalog, the user is able to view WQeMS resources such as products, description, and metadata related to the different open surface water bodies monitored, grouped by themes and categories. The catalog is useful to understand which kind of information the WQeMS system can generate and access to data products. The detail page of a data product includes an example image, quality information, contributors, and other context information. It is possible to export in XML format all of the provided information. The crowdsourcing mobile app is an Android application that offers citizens an intuitive way to report water-related issues. This is done by filling a simple form to define the description and the location of the water issue and possibly attach an associated photo. Instead of a possibly lengthy conversation on the phone, the water operator will instantly have the complete necessary details as posted via the app. Thus, the water company will save human and, at the same time, improve its image since they will facilitate water consumers to submit their complaints. In this example, the user is reporting a complaint related to the tap water quality, which has a strange color. The app enables the user to select the location by taking the one of the mobile phone or by selecting and searching this information through the Google Maps APIs. The user is also attaching a photo to enrich the complaint. These complaints are then visible on the crowdsourcing dashboard, a friendly web interface that visualizes on a map the alerts gathered from the platform and offers filtering capabilities. The platform is also able to collect crowdsourcing data from Twitter and from the citizen observation database CITOBS of the Finnish Environment Agency. All this data is elaborated for the identification of potential water issues. Alerts are generated and notified to the water utility operators. In the dashboard, the user can decide to visualize alerts from Twitter, the crowdsourcing mobile app, and CITOBS by toggling the switches on the interface. Additionally, the user can specify a timeframe to visualize alerts only from this time period. Also, the user can select to visualize alerts based on the event type and the tweet language. Users can also receive alerts based on statistical values obtained analyzing the produced geospatial maps. In this example, the user received an alert email notifying that the value of turbidity detected on Apollofitos Lake in Greece exceeds a predefined threshold. Then, through a dedicated link, it is possible to access the data products that generated this alert in order to investigate the situation. It is possible to customize the alerting functionality through a dedicated section in the portal. The user can create multiple alerts configurations, each of which is related to one water body. In the configuration form, it is possible to add multiple rules. Each rule is related to a phenomenon. For example, turbidity includes a statistical measure and a relationship. In the example, the user wants to be notified if the mean spatial value of turbidity detected on the Ibenstock water body is greater than 25 NTU. The second rule informs the platform to generate an alert if the mean spatial value of the chlorophyll parameter exceeds the 18 ENG M3 value. It is possible to be notified also if specific categories of alerts related to the crowd are detected. Last, a notification method should be selected by specifying between email or API endpoint of an external system, with the possibility to select more than one. The new alert configuration is created and the details can be seen by clicking on the related button. Another functionality provided by the platform is the possibility to generate PDF reports sent by email containing aggregated statistical data about one or more parameters and services applied on a water body during a specific time interval. In this example, the user is specifying an interval of 1 year on the Giretta water body in Italy, including multiple parameters related to the water quality, extreme events, and land water transition zone services. By clicking on Submit, the platform generates and sends a PDF to the specified email address. The report is structured in several sections. First, an introductory sentence summarizing the water body and the period specified by the user when requesting the report. Then, there are tables in which each row is a statistical measure related to the service components aggregated over the period specified. Last, you can find time series graphs that show the trend of each measure during the period specified by the user. Finally, the platform provides a set of mechanisms to integrate functionalities into existing decision support systems in use by water utilities. A dedicated set of API are available for service execution requests, alerts configuration and retrieval, request reports generation, data product and associated statistics gathering. Moreover, to be compliant with legacy systems, the platform provides OGC web services and endpoints which enable to access data using popular, well-established standards.